Hey there, folks. So, last episode we went through and we cleaned up some of the items on our to-do list. Not many, to be honest. It was actually only, I think, one or two. Um, we also went through and created a new define file that we're going to be using for, excuse me, where is it? There we go. Our file path. Right now, that's only being used for the creature factory. The last thing we finished up on last episode was we added our inventory decay logic in so that we don't need to use the onTick function, as that's called every frame, and that's overkill for an inventory component. I went through and mentioned how we could have this as a flat 1 second, and then I sort of went off in a bit of a diatribe and a ramble. But actually, what you likely want there is to use a modifiable one, and I never really quite explained it, but the whole reason for wanting to say group things based on prime numbers is because they are not divisible by anything other than themselves. You're going to keep those groups on independent frequencies. So you're going to have your 3-second group, your 3, 7, I can't even remember what all the prime numbers are. But you're going to have those in independent groups so that they're not going to overlap. And as I mentioned, how if you had something on, say, a 2-second interval, and actually a good one would be a 2-second interval, a 5-second interval, and a 10-second interval. So your 2-second and your 5-second, they're not going to overlap until you hit that 10-second interval. That'll be the 5th time the 2-second interval is ticked. That'll be the 2nd time the 5-second interval is ticked. And then at 10 seconds, you're going to have the 2 group, the 5 group, and the 10 group all fire off. And things like that can sort of cause lag spikes. So I'm actually going to add that here. Use prime number. And I've put that in only as the comment, because then that way it's not mandatory. You are not forcing it to be a prime number, but it's a recommendation. And again, as I mentioned, one of the big goals I have with this project is I want modding support further down the line. So anyways, the other thing I said we were going to do, well, at the end of last episode, what we're going to do is expand our inventory items to offer decay. So that's, say, like you have carton of milk. Sorry, I was just trying to think what would be a good example. It's going to decay. It's going to decay faster if it's in a warm environment. It's going to decay slower if it's in a cold environment. And it's going to, in theory, you get freezer burn and stuff like that, not decay in a frozen environment. So that's something we want to accommodate for. So what we're going to do here is going back to our item base, because I did some thinking between episodes and I decided, like, yes, a clothing item technically will slowly decay over time sitting on a shelf, unless it's made out of like polyester, like man-made fabrics that aren't biodegradable. But things will slowly decay over time. Metal rusts, wood rots, plastics do eventually break down, things like that. So I decided it's something I want to add to the base item, not just consumable items. I want everything to have the potential to decay. So what we're going to do here is, up in our protected section, we are going to add in some new variables. It's going to, I'm going to grab this one here, copy that. So it's going to be bool b can decay. I'm going to default this to false. Grab this one here, sorry. No, float Ambient decay rate. I don't actually want to clamp these. No, that's 0. Float. Actually, no, because I want these to be false by default. I want these all to be 0. Cool decay rate. Cool or cold? I'm going to say cold. Cold decay rate. And then finally float frozen decay rate. So now the whole purpose for this is some things it's actually worse to freeze them than it is to not. I can't think of anything off the top of my head, but there's certain things you don't want to freeze. Can of pop. There you go, off the top of my head, because the frozen liquid will expand, cause the can to rupture. Not a good time. But anyways, so now we've got these properties in here. We're going to want to add in a function. And this is just going to be U function blueprint callable, and it's not going to be no, I don't want it to be blueprint pure. Void decay tick is what I want to call it. And it's going to be float rate. All right, so we've added that in. Before we start doing the logic for this, I'm going to create that definition quickly, actually. I want to go through and actually call this from our inventory component. So, no, that's the header. I want the source file. So we're going to go for const, because we're not making any actual direct changes here. Const auto a in what do we inventory content. I decay. Oh, this is that whole default class right here. I dot. No, how did we do that here? No, it is the get default object. Okay. Why is that not wanting to let me do that? UItem base, get default object. On use, yeah, that's what we want. Is that why? Yeah, decay tick, and then what was it? Tick frequency. So, sorry, that's been a little while since I worked on the inventory, and I'll see the also. Sorry, this is something that unfortunately, because I'm not getting to work on the project as much as I want to. My day job, my code work there, sort of obviously it's my job. Takes precedence in my memory. So the stuff I'm not doing frequently enough with Unreal Engine, I tend to forget. So, but all we're doing here is, so once per interval, be it second, 2 seconds, whatever, we're going through and telling every item in our inventory, okay, we've ticked at this frequency. So going back to our item base now, well, let's go if B can decay. We're going to go if not B can decay. We're just going to return. We don't need to do anything. Simple as that. And this, the whole purpose for this is for code clarity. So if B can decay, return. Ultimately, it's no different than if B can decay. Sorry. So these two here, if B can decay logic, or if B can, or if not B can decay, the difference here is visual, ultimately. Because if this fails, it's going to drop down to here. I'll do this for clarity. Return. So this here, basically saying if we can decay, execute this logic. If we can't, return. This is saying if we can't decay, return, otherwise execute this logic. At a code level for the computer, they are effectively the same. The whole purpose for doing it this way, excuse me, let me delete this because I don't want to leave that in by mistake. The whole purpose of doing it this way is if it can't decay, return. This is for a user reading the code or a developer reading the code. What this is basically saying, okay, the way our code is set is if we can't decay, we're not going to do anything. Don't worry about anything below. That's the whole purpose. Like there's ultimately no functional difference. So anyway, so now that we've got that, we're going to go, there's one thing. Sorry, we completely forgot to add condition. So I want to make sure it's not in here already. Description text. Yeah, we don't have that in there. So that's going to be a float. Item condition. Now this is going to be up to, again, your project, how you want to do it, as to what sort of value you want this to be. If you want it to be a larger value, like I'm going for a value of 100 here. That gives you a sort of you can have more frequent ticks, and it takes a while to go through. You can have more infrequent ticks and things like that. Or you could just go for something like a value of 0 to 1. I'm going from 0 to 100. And then from there, like I said, it's going to be basically a case of item condition, decays. It's like with each tick. Sorry, I'm trying to think how to put this into words. Decays with each tick, and from there, the item condition will slowly go down. Once it hits 0, we're going to add in logic for changing to a decayed item. So, there's one other actual value here we missed. Sorry, this is what I get for sort of doing this all off the cuff. Base decay rate. And this is going to be a value of 1. So now item condition, actually we do want this to be a save game. So we're going to go save game. And actually while I'm in here, can item condition decay. modifier. What the heck is that? Oh, I must have hit the key for that. Modifier for decay at room temp. In fridge, in freezer, item condition, base rate of decay. So now these are a little messed up. I actually want to go through and do some organization within my files, because these should all be grouped in a certain place and everything like that. But anyways, as we go forwards from here, we've got all of the information we need now. So just for ease of my memory, I'm going to move this off to the side so I can see those variable names and not have to hop back and forth. So in here, we're going to go float T decay equals base decay rate times by, I'm just going to go ambient for now, ambient decay rate. Realize we need to change our decay. Sorry, I completely am all over the place and I don't have anything specifically planned for this. So this is a good example actually for you guys why you want to try and plan things out to an extent before you start writing code, because I'm all over the place and not really helping with all of this. So item base. What am I doing? It's open on my other screen. So what we want to do here is we actually need to add in, I want to do this as an int or two bools. Bool cold, bool frozen. I'm going to do this. And what I'm going to do here by default, false, false. And what we've done there is this is just adding, and it's going to come from the actual inventory component that's going to do the tick. Thank you. So this is going to be bool cold, bool frozen, and that should fix that. So this is where, actually I'm going to do it this way. So it's going to be if cold, else if frozen, else. So normally I don't like if else if because it can get a little confusing, but because we want only one of the three potential conditions, ambient, cold, or frozen, we don't want to worry about all three of them. We need to use a multiple else if. So the other thing to keep in mind when you're doing an else if is the order you want to do them in. So if, for example, this comes in as both cold and frozen are true, we're going to treat it as cold instead of frozen. So I'm actually going to switch these around. We want frozen to override cold. So then we're going to go T decay, thank you, times equals, and then that is where we're going to use our frozen decay rate, else T decay times equals our cold decay rate. Otherwise, it's going to be obviously T decay times equals ambient decay rate. And then finally, Sorry, I'm elbowing things on my desk here. We want to modify our condition. So it's going to trying to think basically. Now we want this all to be based on a per second decay rate. So this is going to then be T decay, because we've done all of our calculations, times equals rate. And then it's going to be item condition minus equals T decay. And the way this logic is going to work, we're going to say our rate is 1, we're not cold, we're not frozen. So we're going to hit this condition here. Our ambient decay rate is 1. So T decay is going to stay at our base decay rate of 1. Then we have our rate of 1. Well, that's going to just mean 1 times 1 is 1. Item condition drops by 1. If we're frozen and our frozen decay rate is 0, well, T decay times base decay rate is 1. Our frozen decay rate is 0, so that drops T decay to 0. Doesn't matter what our rate is, 0 times anything is 0. So our item condition is never going to drop. Our cold decay rate we'll say is 0.5. Our rate is 1, so our base decay rate drops down to 0.5. Our rate is 1, so that's 0.5 is going to stay 0.5. Our item condition is going to drop by 0.5. Say our rate is 2, that 0.5 then becomes 1. So that is going to be how we're going to want to work that out there. Ultimately, saying this, I just realized, again, because I haven't pre-planned any of this other than I wanted to have item decay. That rate is also going to be wanting to be modified. You're going to want to modify that rate by a factor based on this. It's up here. We have our day length. So this is going to, you're going to want to modify this by, say, if you're running a 30-minute day versus a 60-minute day, things are going to decay twice as fast on a 30-minute day as they would from a 60-minute. So that is something you're going to want to account for as well, thinking of that. So I'm trying to think how I would want to do that off the top of my head, actually. So trying to think, what was my default? I think that was going to be my default, 2 hours. No, 60-minute was going to be my default. No, I'm not going to do that yet because I'm not sure what my default time is going to be. So anyways, so what you're going to want to do, you're going to want to find what is going to be your project's default day length if you have variable day length. And based on that, that's how you're going to want to do all your calculations. So it's going to want to be a case of, okay, my default is a 60-minute day. I'm going to have 30-minute means I need to multiply by 2, 120 is divided by 2, 180 is divided by 2.5, so on and so forth. So that is also something to keep in mind. If and when I do, well, not if, but when I do this, what I'm it's going to be a case of trying to think where to do this. Probably in the inventory, because then you're only doing a value once. So what it would be is up here we'd be like float adjusted rate equals tick frequency times by well, equals tick frequency. I'm just commenting this out here, times by day length multiplier. And then you would pass that through. And what I would also suggest with that, and what I'm going to do, but if anyone wants to sort of jump ahead, because I understand I'm only doing this once a week right now, day length multiplier would be something you would want to calculate and assign as part of begin play. It would be like, okay, reach out to the game instance, get the day length multiplier, and then from there store it locally, because then it doesn't have to constantly reach out to the game instance and go from there. So, but anyways, folks, again, slightly on the shorter side. We're only at 25 minutes here, but I don't want to start jumping around into another topic just yet. I need to actually sit down and go through and figure a few things out. As you notice, I've been a little scattered this episode and the last episode because I'm working off script, basically. Nothing is scripted out, just to be clear. I have my game design doc that I normally work from. There are certain things that I haven't fully worked out in a way that fits with the way I'm doing the game now. I have in my game design doc information around item decay, but it doesn't work with how I've implemented things. It was all based off tick. It was all based off of like the inventory component itself did all of this, which, being a data class, you'd almost think that would be the right way to do it, but I don't want that in the inventory. I want to try and keep things as simplistic as possible. Saying that, I need to reevaluate this and decide, okay, because I'm not sure on this functionality, the cold and frozen. I'm not sure how I want to do that. But on that note, actually, before I wrap this episode up, thinking about it, inventory component. Down here we have this. You can see this function is perfectly fine. It's not throwing an error. That is because we gave those a default value of false for both the cold and frozen. So that value, it's just going to assume it's false because we haven't passed anything in. So what I will do to end this off, though, I'm just going to run a quick build. I'm not actually going to launch into the editor or anything, but we will do a quick build, make sure I haven't broken any code here. So, but with that, I will just quickly say next episode, I'm not sure what it's going to be at all at this point. I need to go through and plan some things out. I need to actually sit down and document some stuff because, as I said, I'm a little scattered right now and all over the place. The downside of doing what I'm doing now, which is like just coding off the cuff, you tend to, well, when you're spitballing ideas, and like right now it's early in the project, so it's not a huge issue. When you're spitballing these ideas, you tend to write things in the first way it comes to mind, and that's not always the best way to do it. Sometimes you're going to want to work things out in a slightly different way. So I like to, even in today's modern day, everything's digital, I still handwrite 99.9% of my notes. So basically that's what I'm going to be doing. I'm going to be sitting down, working out some documentation. I'm going to reevaluate this decay functionality and the item conditioning, and make sure the way I'm doing it is the way I want to do it. But anyways, folks, as you can see, this build has succeeded. We haven't broken anything. What we will do is, I'm going to end the episode here. We're now actually, I've talked for nearly 5 minutes. So I am going to end the episode off here. As always, if you do have any comments, questions, concerns, suggestions, or anything like that, please feel free to leave them in the comments below or hop over on the Discord and ask your questions there. I try to respond as often as I can. In the Discord, I can help out a lot easier because it's sort of it's live, B, file sharing, things like that, because sometimes you may run into issues that I need to look at a file you've written. But anyways, folks, as always, thanks for watching, and I will see you in the next episode.